just visually, right, what does that look like? I don't know where to put this bar so it doesn't get in my way. Visually, right, it looks like there is a partition at -1 and then there is another partition at 2, right? So at -1, which two graphs meet up at that point at -1? Well, at -1, this one and this one meet up, right? So what you do in order to test for continuity is this. You take -1 and you plug it into that function. And you say at x equals -1, so that function is to the left of -1, right? So the left is y equals 3 times -1 plus 2, that's -1, okay? The right is just that second function, and y is just -1. Okay, so you see how they have the same value, right? And now you look at this and this, the inequalities. One is open, one is closed, right? So at -1, one function has a value of -1 and it's open. The other one has a value of -1 and it's closed. So that means we're going to close it there, right? So what does that look like? If they're both the same value and it's closed, it's continuous. Okay, because if you look at the function, you know, one graph is a linear equation like this and the other one is just -1. So do you see how it's continuous there? So what happens here? It's the same value plus it's closed. So that means it's continuous. Okay, what about at the other partition here? Right, at x equals 2. Which two graphs meet up at x equals 2? Well, one is this one, -1, and then the other one is x minus 3. So at x equals 2, from the left, y is -1. Okay, and I go here, it's -1. Is it open or closed at 2 for that one, for the second one? It's closed, right? And then from the right, if you plug in this one, you get -1. And it's open, so again, that means, you know, it's continuous, right? Same value, closed, continuous. So this is continuous everywhere, or you would say there are no discontinuities, you know, there is no, you know, just get the message across. There is no set way. Okay, and then here, take a look at this one. I've got, again, two partitions. One is at x equals 0, and the other one is at x equals 1. Okay, so I'll make that x equals 1, and this is x equals 0. Okay, so which graphs meet up at x equals 0? It's the first and the second. So I say, okay, from the left, plug in 0, y equals 5. From the right, plug in 0, y equals 5. Same value, right? But is it open or closed over there? So it's open, right? The first one, it's y equals 5, and it's open. The second one is y equals 5, and it's open again, right? If it's the same value, but open, then it's a removable discontinuity. Okay? Because what does it look like? From the left, it's 5 minus 2x, so it's something going down. And then it's x plus 5, so it's something going up. So do you see how it's a removable discontinuity over there? So again, same value, open, removable. Now, what's the other option? At x equals 1, from the left, it's this one, 1 plus 5, 6. Okay, so from here it's 6 and it's closed. And then from the right, you plug 1 in there, y equals 3 minus 2, it's 1 and it's open. Okay, so this one, it's not even the same value. You have different values. It doesn't even matter if it's open or closed. It's a jump discontinuity. Right? Do you see how it jumps over there? So this one is like this. Okay? So with these, you plug in the values at each point. To summarize, if it's different values, it's jump. If it's the same y value, then you have two possibilities. Open means removable. Closed means continuous. Okay.
So what would the answer be for this one?
Oh, yeah, sorry. So you would say removable at x equals 0, jump at x equals 1. Thank you, Tal.